Hello students, I am Dr. Gajendra Purohit. Today, I will start with composition of functions. I have already uploaded many videos on discrete mathematics. And if you like this series, further I will also be bringing more such videos. The videos will include many topics such as graph theory and many other topics. So, in the composition of functions, there is GOF and FOG. Now, we will discuss about GOF and FOG. What are they? Are they equal or not? And are their inverses equal or not? There are a lot of questions asked about this in exams. We will discuss it all. Students, watch carefully. Now first, we will talk about the inverse function. So if f x to y be a bijection, meaning if any function that we have here is defined from x to y, and it is both 1, 1 and onto, then its inverse will always exist. In other words, it means that its pre-image will always exist here. So now if it is onto. But what is onto? Its pre-image must always exist, right or wrong? Its inverse exists here. And what is it always? It's a unique element. I have already uploaded a video on this. You can find it on iTab where I have explained 1, and onto functions along with range, domain and codomain in detail. Now let's move further. Let's take an example. We know that f r to r f x is equal to 2x minus 3. This function is 1, 1 and onto. If it is both, how do we find its inverse? Take this as y, then we will get y is equal to 2x minus 3. So, we will have 2x is equal to y plus 3, then we get x is equal to y plus 3 upon 2, and then we get this as f inverse y, right? Keeping this in mind is important. Now, here we have y plus 3 upon 2. This means that its inverse exists and we can find it using this method. Moving on. Now, we'll discuss the composition functions. So, what is composition function? If f is defined by a to b and g is defined by b to c with a 2 function and their function g o f a to c, where g of x is equal to g of fx. For all x belongs to a is the composition function of f and g. What is the meaning of this? So listen, if we have any function where f is defined from a to b and g is defined from b to c, so the function that goes directly from a to c, which means that it bypasses b altogether, then that function, what is it called as? It is called as the composite function. We denote this function as g of f. It means that this is f and this is g. So the function we have here, it will directly be denoted as g of f. And we denote this function as g of f. And the g of f that we have here is like g of fx, which means g of fx. Is it right? I will show you how to calculate the values for this. For example, I want to tell you here that, let's say we have a function here, f, which is from r to r. And here we have x square plus 1. The function here is written as x square plus 1, and the g that we have is written as 2x plus 1. The question here is, what is the value of g of f? How do we calculate the value? Now pay attention to this. G of fx, the value of x is taken out here as g of fx. What do we have fx here? It means x square plus 1. So we will write it as x square plus 1. So it will be x square plus 1, right? We know the value of gx. So this x here is brought over here. It means that we will get x square plus 1 in place of x. This will be 2x square plus 1. Now if we will solve this equation, then we will get 2x square plus 3, which is equal to g of x, right? So we take out these values like this. Let's move forward now. Let's understand this. If a is 1, 2, 3, and the mapping given is defined from a to a. Suppose you are asked that if mapping is of this type, and if I write it here, that is we have it written as 1, 2, and 3. So, we have been given 1, 2, 3 and the mapping is given as 1 maps to 2, 2 maps to 1 and 3 maps to 3, right? So, this is the type of mapping given to us. This is A from A to A and we have F here. So, this has been given to us. You all were asking how to calculate the values of F inverse, F2 and F cube, right? So, I will tell it to you one by one now. If you've studied permutations, then this is just a permutation concept. You can connect this to permutations as well. So now listen, firstly, let us say here that we have been given f1 will be linked to f2. And see now, f2 here is linked to 1 and f3 here is linked to 3. Is it right or not? If you have been asked what the inverse of this will be, pick up f and bring it here. Then f inverse 2 will go over 1. F inverse 1 will map to 2, meaning f will map to that location. And then what will be f inverse 3? So f inverse 3 will map to 3. This will be 1, 1 and on 2. So the inverse will exist here. And now if we write this here, then how will we write it? F inverse will be written as 2, 1, right? So we write it like this, 2, 1. And this here then will be 1, 2, right? And then we have 3, 3. By the way, all you need to do is flip it, just reverse it. If it's 1, 2, then write 2, 1. If it's 2, 1, write 1, 2. And if it's 3, 3, then that's inverse. We can understand this very easily in this way. So next you will be asked what the value of f square will be, right? So the meaning of f square here is that it is the value of f o f1. If you are asked to find the value of f square 1, if I ask you how to calculate the value of f square 1, f square 2 and f square 3, so ultimately it happens that if we write it here like this, f of f will be 1. And where does f go? F maps to 2. So I can write that this will be f2 and 2 maps to 1. So this will be the value of it. If you will be asked about f2 and 2, then I will change the color here so that it will be easy to understand. So see here we will get f of f2, right? So then I can write this as f of f2. Is it right? So where is the value of f2 going? So f2 maps to 1 and f1 maps to 2, right? We'll discuss the same type here. This will be f of f3. So now if we can write this as f of f3, and f3 is mapping to where? 3. So this is mapping back to 3. So is this correct or not? How will we write this? If we write the value of this, then what is the method of writing it? How will we write f square? See, the image of 1 is represented as 1, so we will write it as 1, 1. So now you all can see here that the image of 2 is represented as 2. And you can see here that the image of 3 is represented as 3. So this is an identity function. If any image is represented by itself, then it is identity. And when we always have this type of order 2, ultimately what will happen here is the inverse concept. You can easily connect permutations to it. Likewise, when you are asked how to calculate the value of f cube, then similarly here we will take f cube. You don't have to do anything here. Just take 3 here. And then we will take this f of f here, right? Now we will take this out one by one and I will show you one by one. So you can understand the method here. Now if you are asked how to calculate f cube, here I will make you understand how do you calculate f cube. F cube can be calculated easily. Here we will talk about f cube 1. If we take f cube 1, then we will write this as f o f o f1. If we write this as f o, then we will get f of f1, right? Now we know the value of f1 that we have is 2. So we will get this as f o f2. Is this correct till here? Now further we can write this here as f of f2 and the value of f2 maps to 1. Okay. This will be f1 and now here f1 maps back to 2, right? So this is how we get the values. So now what we will do is calculate the value of f cube 2 here. Please note that we can write this as f o f o f. So to this we have 2, but we know that f square is 2 and the value of f square 2 is 2, which maps to 2. So if we write f square 2 here, then we will get the value as 2. Because its value is 2, I just explained it. For this f2, the 2 here maps to 1. So this is the value that we will get here. Similarly, we can calculate the value of a cube of 3, which can be written as f o f o f of 3. And we know its value is 3. For the 2 order, f square 3 maps to 3. Here we will have 3, so we will write it as f of 3 and this f of 3 will go to 3. So students, 1 will go to 2. If we are talking about f cube, then what will be the value of f cube? So here, where does 1 get mapped to? 2. Where does 2 get mapped to? 1. And where does 3 get mapped to? 3. In this way, we can easily calculate it. We can also understand it in this way. We can write it as f cube is equal to f into f square. This is an identity. We will have f into identity that is equal to f. So actually it equals to f, right? In this way we can easily understand it. Let's move ahead. Now look at this question. f a to b and g b to c be the 1 1 and onto function, meaning f and g are both 1 1 and onto function. So now here you need to find whether g of f, that is you have to prove that g of f is 1 1 and onto function. The inverse of g of f is equal to f inverse or g inverse. Notice how it reverses here, just like we see in matrix. The inverse of ab is b inverse a inverse. What do we have then? It is a property. You have to prove it. Now first we will prove that g of f is 1 1. Then secondly we will prove that it is onto. But now what's the definition of a 1 1 function? So now if we have x1 and x2, then we know that f x1 is equal to f x2. What does this mean? It means that x1 is equal to x2. So now we can do this for g also. So if we have x3 and x4, gx3 is equal to gx4, then x3 is equal to x4. So now let us prove whether g of f is 1 1 or not. To do this we will take x1 and x2. So listen now, what do we do here? So now here g of f, I will take it as x1 is equal to g of f x2. Is it right? And so now if I will prove here that we have x1 is equal to x2, then this GOF will become a 1, 1. If the values of the functions are equal, then the points are also equal. So what we will do here is take GOF as x1, then similarly we will take GOF as x2. Now this will be, but before that, see here the G we have is a 1, 1. So if G is a 1, 1, then what will be the value of its point? So students, it will be equal. We know the definition of 1, 1 in the case of G. If I say here x3 equal to G is equal to x4, then it implies that x3 is equal to x4. If G is 1, 1 and if it is given this in the place of x3 and x4, then what will it be? It will be fx1 is equal to fx2. F is 1, 1, then what will we have? x1 will be equal to x2. Now if this is equal, then this is also equal. It means that this is 1, 1, so we can prove it easily in this way. Now we will talk about onto. So whenever we talk about onto, we always talk about the pre-image, right? If we have a point, then let us assume that this is x, this is y, and this is z. So see here what we will do is, we will take an element y whose pre-image exists as x, and similarly, we will take a z element whose pre-image exists as y. In the case of GOF, you need to take an element whose inverse image already exists and pre-image also exists. Now we will consider all of this. But how will we solve this? Let us see. What will we do here now? Right? That is what I am trying to tell you. So listen, this is what we have here. We have this as A, this as B, and this as C. Firstly, what we will do is take an element x belonging to B, and similarly, we will take an element y. What will we prove now? So now we will assume A to B that we have been given. F that is given is what? Onto. Now meaning here the pre-image exists. It means that the image for x and y exists. So what is the meaning of this? So it means that Fy is equal to x. Similarly, in this type, if we take an element z here, then the pre-image will exist. So, meaning for Z, a pre-image exists in X because what is B to C that is given to us, it is given as onto. What does it mean? So, it means that Gx will be equal to Z, right? Now, what do we need to prove here? We have been given GOF here. So, we need to prove that GOF is also onto. What we will do is take an element here, GOF. And here we will take an element Y. So, take GOFY. And we know here that for GOFY, an element exists here. This means that its image exists, right? As I informed you before, that x has a pre-image y, so what did I do? Fy is equal to x. Similarly, in this type, we will prove that for y. For GOFY, an image exists, which means that its pre-image also exists. This is what we will do, right? So what we will do here is for g of, we will get Fy. And what will be the value of Fy? It will be x. So we will take this as gx. What is gx here? It is z. This means that for each y, we have a z. So obviously for z, we will have a corresponding y, which exists here. In this way, we can easily prove it. And what is this here? It is onto. We need to prove that GOF inverse is equal to F inverse OG inverse. What we will do here? So firstly, we will talk about GOF and find the value of y, right? So see, this will be GOFY, right? And here what have we taken Fy as? Fy is x. Then this will be Gx. And now here what is the value of Gx? It is z. So students, now listen here, we will get GOFY is equal to z. When I will bring this to the other side, what will we get? We will get GOF inverse z is equal to, we will get y, right? Now see what I will do here. Please pay attention now as I will calculate the value of F inverse O, G inverse z. If I will bring this value also as y, then it will be proved accurately. So if I now go forward with this to prove it, see this is equal to y, then we will bring this also equal to y. How will we do this? Take a look here. Here we will get F inverse. So we can also write it as G inverse of z, right? And for G inverse z, if G comes to this side, then the value of G inverse z will be x. We will get F inverse x. And if F is brought to this side, then F inverse x will be y. So listen, we have this equal to y and we have this equal to y. What does this mean? It means that GOF inverse, what will it be? So here F inverse, so it will be equal to G inverse. So we can easily prove it in this way. Let's look at this question. It's a very good question. If Fx to y and AB are two subsets of x, then prove that Fa union B is equal to Fa union Fb. And also prove that Fa intersection B will be a subset of Fa intersection Fb. This is very simple and we can easily prove it. First of all, we will consider an element here. So now firstly, here we will take an element x and then we will say that the x which we have here belongs to Fa union B. this is an element of this, then we will say that this x also belongs to this. So this will be a subset. Again, we will take x from here and show it here. So then this will become its subset, and as a result, they will become equal. We will prove it like set theory concept. If I bring f to this side, then what will come here? F inverse x will belong to A union B. Now, if f inverse x belongs to this union, then listen what will happen. And what does it mean? It means that f inverse x will either belong to A or f inverse x will belong to B. Isn't it so? It will either belong to this or belong to this. If it belongs to this, then I can write that x belongs to FA, or x will belong to, what will be here? It will be FB. So this f goes back to the other side again. So if this is there and if it belongs to this, then what will happen to x students? It will go to FA union FB. If I will now take x and bring it to this side, then what does this mean? So listen, this means that FA union BB will be a subset here of FA union FB. Now let's consider the reverse. I'll use a different color for this. Let's prove it in the opposite direction. Let's assume that x belongs to, let's take it as FA union FB. Assume this. So I will take it like this. So now if it belongs to this, then it implies that x belongs to FA or x belongs to FB. So I brought it here. If this belongs to this, then tell me what will happen. This means that if f inverse x belongs to A and f inverse x belongs to what will be here, it will be B. This means that it will either be in this or this. The meaning of this will be that f inverse x here, it will belong to A union B, right? So the meaning of this will be that x belongs to F A union B. So if we bring this here and show this here, then it means that we can say F A union FB will be a subset. So is this right? So now here this means that we have a subset F A union FB. Isn't it so? This is a subset of this and this is a subset of this. It means that both of these are equal to each other. Now let's move on to the second part. Let's assume here that x belongs to F A intersection B. We will take it like this. So what will be the meaning of this? It means that f inverse x, what will it be? It will belong to A intersection B. Now the meaning of this will be that f inverse x will belong to A end. So students, this will be end here and f inverse x will also belong to B. Is it right? If it maps to B, then I can write it as x belongs to will map to FA and x belongs to will map to FB. So is this right? Now if it maps in both, then x will be in their intersection. So FA intersection here will be FB. So now we have proved that if we take an element here and if we apply it here, then it will map to this. So it means that FA intersection B is a subset of FA intersection FB. Is it right? And in this way we can easily prove it. So next let's move ahead. The next question is if f r to r and fx is equal to x square and g r to r. Here gx is given as x plus 3. Then we have to prove that FOG is not equal to GOF. So listen, first we will talk about FOG, right? So what will be the value of FOGX? So now what will be here? If we take f of gx here, then what will be the value of gx? It is x plus 3. So we will get here fx plus 3. Is it right? And here we have fx, so x goes to this side and becomes the square of it. Here we have x plus 3, so this will be the whole square of x plus 3. If you open it up, you will get x square plus 6, x plus 9. So now listen, we will talk about GOFX, right? We can write this as GOFFX, right? In this case, we are getting the value of fx as x square. And whatever x is there, it becomes x plus 3. So if we will do x square plus 3 here, but here we have x square plus 6x plus 9. So here we have x square plus 3. It means that these both are not equal to each other. This means that FOG will not be equal to GOF. We can prove it easily in this way. So this is the question. You have to answer it in the comment box. And how much time did you take to solve it? Please let me know. Also, if you want to do good in discrete mathematics, then you can watch the complete playlist here. Listen, I have started a new series for part C. If you are preparing for CSIR NET, GATE, IIT-JAM or any other exam, and if you want to solve question, then you can watch good tricks here. You can subscribe to my new channel here and follow me on Instagram here. Thank you so much for watching me. Please like, share and subscribe to the channel. Do answer the question in the comment box. Thank you.